It's 7:03, and I'd like to call the October 23rd, 2020 Houston Region All Clubs meeting to order. Good evening, everyone. My name is Joe Califf. I'm the president of the Houston Astronomical Society. And on behalf of all of the other club presidents and officers, I'd like to welcome you all to the 2020 Houston Region All Clubs meeting. Before we get started, I'd like to say that Astronomy Day and the All Clubs meeting that precedes it are a highlight of the Houston amateur astronomy community. This year, as we're all aware, we've been presented with an unprecedented challenge due to COVID-19. And although we can't bring our telescopes out to the George for a night under the stars with the public or gather in person for this event, we're thankful that we can be here tonight to listen to a great talk from our friend Robert Reeves. But before I hand over the virtual microphone, I have to acknowledge the effort of David Haviland in working tirelessly to bring the All Clubs meeting together. Just as it looked like the meeting might be yet another thing canceled due to the pandemic, David doggedly held things together to make sure that we could all join here as a community of astronomy enthusiasts tonight. And to do so while getting a main speaker of Robert Reeves' caliber is just icing on the top. So I'd like to personally thank David for making this all happen tonight. Thank you, David. And now, without further ado, I'd like to introduce our good friend, Mr. David Haviland. David, take it away.
All right. Thank you very much, Joe. As I said, we've gathered in front of our media of choice, and I want to take a few slides and thank people who have gone above and beyond the call of duty. So I'm going to turn that around on you, Joe. Thanks to you and Don, who kindly offered the use of the HAS's Zoom account, without which this wouldn't be possible. The Astronomy Day Committee, I have a slide for them next, and I still want to thank Tracy Gnoss at the George. We were trying to see if we could do a day at the George, which would have been tomorrow, first quarter moon, as we always have it. But even as far as out to the beginning of September, those discussions were still underway, but then it just fizzled out. So we still appreciate her efforts. She is back at the George, efforting getting it, trying to see if they can get it open first quarter of 2021. And very quickly, our good friend Aaron needs to make a very quick announcement. So for 20 seconds, I want to throw it in Aaron's direction.
I'll even try to give some of that time back to you. Thanks, David. So if you are one of the students from Lone Star College Montgomery, I wanted to remind you to please make sure you send an email to, if you're one of mine, to me, or if you're the other professors, please send it to her. It's very important for you to get credit for being here because not all of you have your name on the list as your name. Thank you.
All right. The A-Day committee is otherwise a very full operational committee. I know people have been on committees where you feel like you're the only one doing the work. That is not true with this committee. It's a broad committee represented by many, many clubs, as you can see here. Now, we didn't exactly do a lot this time because of the pandemic, figuring out what to do, if anything to do with A-Day, and then ultimately to try to have an all clubs meeting as we go. For Robert's interest, and also Joe and I were talking last night, the clubs have also enjoyed a new membership, as well as telescopes that you can hardly find on the net as being available. And as an odd sidebar, RVs are kind of hard to come by. So the pandemic has had some interesting side consequences. So it's possible that we have new members at this All Clubs meeting that may not know what Astronomy Day and the All Clubs meeting is. So I'm going to take a few slides for that. The All Clubs meeting is traditionally held the Friday before Astronomy Day, which we have at the George. And it's where all of the clubs in the Southeast Texas area get together. And all those clubs will be listed shortly. So again, I want to thank everybody on this list for what they've done, and to Mark Holsworth for hosting the Astronomy Day website. Oh my God, where did my picture go? Okay, there it is. I forgot about it, had the animation there. On Saturday, we otherwise would be hosting the Astronomy Day at the George Observatory, and you've got a map of Houston here, and it's down here at the Brazos-Bend State Park. And we've got the East Dome, Research Dome, West Dome, and the large deck area. And in the East Dome, we have an 18-inch reflector. Research Dome is a 36-inch Ritchie, and the West Dome has one of my favorites, is a 14-inch SCT. And on the deck of the George, we have room for 30 scopes, and we will have people all over the deck here, lined up at various people's scopes. The door to the 36 is roughly here, and the people will wrap around the building one and a half times. Same for the East Dome and West Dome. We've had quite a number of activities going on, from face painting, Debbie Moran talking about light pollution, outdoor talks, clubs table, indoor talks, button making, you name it, we have it going on. Deck activity here, kids activities here. Occasionally we've had the Lunar Planetary Institute come out, and they will do a phase of the moon study with Oreos and let the kids have the Oreos. And some pictures here taken of Astronomy Day at night. I hopefully didn't miss anybody, but most of these pictures were provided by myself, Steve Goldberg, Chris Randall, and Sarah Silva. Houston Astronomy Day past attendance has varied. I only have records back to 1999, roughly around 2001, when Connie and I got involved with it. And as you can tell, there's some days we have had quite a number of people come through, not all at once, but it's a constant stream of people. We've also had our hat handed to us weather-wise. Rain killed this one. Obviously, Tropical Storm Harvey killed this one. The George has underwent some renovations. We had to move Astronomy Day to Insperity last year. This year is out. Between renovations and the pandemic, we're out. Hopefully 2021 will be the restart for an awful lot. I'd also like to throw in a big push for Aaron Clevenson's Insperity Observatory. This is to the north, just up near the airport. Aaron has twice tried to run a springtime A-Day, and the events have come out very successful, but weather has not been a very compliant friend. He has an exceptional setup up there, and if you are new to the area, a new member of the clubs, by all means, at an early opportunity, Aaron will tell about later, but he has, I think, an open viewing on the first Friday of the month. He has some exceptional hardware up there that's well worth the trip. The 6-inch tack, the 14-inch me, the 20-inch plane wave. And these are pictures from when we had Insperity up there. Aaron, I always love this map, the star chart you've got on the wall here. But we've had some of the same activities going on there that we have at the A-Day at the George Observatory, and getting ready for an evening. And that's pretty much all I was going to say about the A-Day at the respective places. Hopefully weather, pandemic, 2021 will be good for both the A-Day at the George and A-Day at Insperity. So at this point, I'm going to slide over to Leonard.
All right, good evening, everybody. Again, thanks for being here. And at this time, we're going to go ahead and introduce the clubs. I am not sure who's representing. We've got, we go to the next slide, Dave. So what I'm going to do is introduce each of the clubs. If you are here representing your club, please come off of mute and acknowledge. And then after we get through with this slide, we have a independent slide for each club for you to come back and talk about your club for a minute or two. So we'll start with the Astronomical Society of Southeast Texas. Will Young, President.
Yep, I'm here. How you doing?
Good evening. Community of Humboldt Insperity Observatory Society. Aaron Clevenson.
I'm here. Good to see y'all.
Fort Bend Astronomy Club. Tony Weezy.
This is Wayne Wiegand, Vice President. I'm holding the fort down for Tony.
Good evening, Wayne. Houston Astronomical Society. Joe Califf.
I am here.
Huntsville. Mike Prokosh. Mike didn't make it. Johnson Space Center Astronomical Society. Doug Holland.
I'm here.
Good evening, Doug. North Houston Astronomy Club. I don't know if Carlos is on.
No, but Bruce Pollard, Vice President, is here in his stead.
Okay, Bruce. And for the George Observatory, I don't see Tracy. Okay, Tracy. Okay, so let's go back to the slide for to Will for the Astronomical Society of Southeast Texas.
Yeah, hey, we're the Astronomical Society of Southeast Texas. We're a club over in Beaumont, and just on the very verge of Southeast Texas, over there in the corner, sort of. You know, we're a club that's been around for a while now, and we do a lot of outreach. You can see the stuff there. I won't go through the whole thing, but we're a small club. We're a lot smaller than HAS and the like, but we do have a lot of passionate observers. People like Howard Miner, a good friend of mine, Bill Christian, Eddie Trevino, and others, many others. A lot of volunteering at star parties. We do heavily volunteering at Texas Star Party and El Dorado Star Party, which we just got back from. And it was pretty awesome. We had a home run star party. Every night was observable, which was absolutely fantastic. But that's us. We meet on the second Friday of each month. Well, when COVID's not around, at the planetarium over here in Beaumont, the BISD planetarium. Sharon Rigsby is our host there, and that's us. Thanks for having us, and appreciate all the other clubs in the area for sure.
Aaron.
All right, thank you. So I'm Aaron Clevenson. I am the Observatory Director at the Insperity Observatory up in Humble. And we do have what we consider to be an astronomy club. It's the Community of Humble Insperity Observatory Society. And we do meet on the first Friday of each month for observing. And we are doing observing, but we're doing it under COVID-19 protocols. So we actually do not let anybody but the astronomers in the observatory. And I should mention Bruce, because Bruce has been our major technical person on that. And we do require reservations. The next time we're going to be open for the public is actually our grand reopening, and that's first Friday in December. And we've done a couple dry runs. They've both been very successful, and so we're looking forward to one more dry run before the real thing. We meet at the Insperity Observatory in Humble. I put the link up here on the slide for anybody who wants to go check out the observatory. And if you have never been to us or didn't know about us, that's appalling. We've been there for about 11 years. And on our membership, we have 1,448 members as of today. And membership is free to all. So if any of you would like to be on our distribution list, we'd love to add you. And the odd thing about our astronomy club is we don't have business meetings. So that's about it for me. And I hope to see you all at the observatory.
Wayne.
Oh, howdy. Hey, just wanted to take this opportunity to show some praise for our members, current and past members, for all their efforts over the years doing outreach. We been doing outreach for 35 years. And we got some recognition, national recognition for outreach from Astronomical League as well as Night Sky Network. We've provided strong SEM support for Fort Bend County Schools and strong support for the George Observatory, providing volunteers for the decks and all the domes, etc. So just to wrap it up, I just wanted to hats off to the members of Fort Bend Astronomy, and hats off to all the clubs around the greater Houston area. We are doing a big service to the community, promoting astronomy and science in general. So thank you.
Joe.
All right. Well, the Houston Astronomical Society is one of the oldest amateur astronomy clubs in Texas, as well as one of the largest in the United States. I think right now we're somewhere north of about 620 members. And like many of our other sister clubs here, we've seen a tremendous amount of growth over the last year. As you can see there in our mission statement, our focus is on not only our membership, but also the community. And we take pride in our wonderful amenities and the programs that a lot of our tireless volunteers work hard to make happen. I always say our membership is our #1 asset, but based on the picture there, you can see our #2 asset, best asset in my opinion, is our dark site, which is located approximately 75 miles west of Houston. It's open to all of our members and their guests 24 hours a day, 7 days a week, 365 days a year. I'm also very proud of our Loner Telescope program and our active outreach program, which in a non-COVID year typically has at least one event per week, 50 plus per year. We usually conduct our meetings first Friday of the month when we're not dealing with a pandemic. We still do that, but virtually now. And we'll have our novice meetings the Thursday before. So any information you'd like about the club, astronomyhouston.org. Our meetings are open to the public and we'd love to have others join. So thank you all for joining us tonight.
Doug.
Yes. Okay. As you said, I'm the president of the JSC Astronomical Society. Our vice president is Chris Wells. We meet on the second Friday of each month at 7:30. We meet in person. We meet at the Lunar Planetary Institute, which is the corner of Bay Area and Middlebrook in the Clear Lake City area. When we're not meeting in person, we're having virtual meetings. We have a YouTube channel, which you can find on our webpage, www.jseas.net, and you can participate in those meetings at the same time. Our club has no dues, no bylaws, so membership is just by participation. We do a variety of events during the year. We go out to the Fort McCavett in the spring and the fall for 3-night star parties, and we do lots of other star parties and other outreach things in the local areas. Those are all listed on our calendar on our webpage. So that's about it. Anyone's welcome to participate in our club if you have an interest in astronomy. Thank you very much.
Bruce.
Oh, hi, I'm Bruce Pollard. I'm here instead of Carlos. I'm the vice president of North Houston Astronomy Club. We're about 25 years old now, and we meet on the fourth Friday of each month, or we've been doing some Zoom things lately. Our next one coming up is on use of different kinds of gratings to do spectrometry with the guy who writes the software for us. We have a number of outreach things that we do. The local schedule that we're still trying to work in. Of course, we work with Aaron's Observatory, and we also have a star party in the spring and fall at Atascocita. And then we have different scheduled things at Region 4 of the county area at Punt Park and at Jesse Jones. We have a website that www.astronomyclub.org that we keep up to date. And we have a dark site with a really good Western and Northern and sky, so we can see lots of good stuff. And everybody's invited to, if they're members of our club, to use that dark site. And we have a loaner program too. That's it.
And finally, I guess the George. I think Dave covered the George pretty well.
Covered the George, and it'll be open when it's open. It's sad, but I was looking it up with Connie this morning, and for renovations, it was closed the last week, and we were both building managers there, which was, I think, the 27th of July, 2019. And it was supposed to be open February of 2020 after the renovations. And then everybody knows what happened with February and March. All right. It is our delight to have Robert Reeves as our speaker. Robert has been exploring the moon since 1958 and took his first lunar image in '59. He began telescopic astronomy with a 4-inch Criterion Dynascope. Apparently it was a Christmas present in 1960. In 1975, he acquired a Celestron 8 telescope, which he still uses today. In 77, he acquired a Celestron 8-inch SMIC camera that he used for a quarter century for deep sky photography. And correct me if I'm wrong, but I believe that was a film camera. Today, Robert uses a Celestron C11 Edge HD, as he used the Skywatcher 180 Max Sutoff and the Skywatcher 20-inch Stargate telescope for lunar photography from his perspective observatory located in Central Texas. He's just recently got this monstrosity here to the, enduringly I say, to the right here, the Celestron C14 Hyperstar for deep sky photography. He began publishing articles in 1984 about astrophotography in Astronomy magazine, and has since published over 250 magazine articles and 200 newspaper columns about astronomy. His articles have appeared in Sky and Telescope, Astronomy, Deep Sky Journal, Amateur Astronomy, and the Astrograph. He's published his first book, The Superpower Race Space, followed by The Conquest of Space, co-authored by Fritz Bronner. But in 2000, he published Wide Field Astronomy, Introduction to Digital Astrophotography of 2005, and Introduction to Webcam Astrophotography. All of these still currently in print by Wilman Bell. His latest book about the moon is currently under editorial review. Although he's an accomplished and deep sky astrophotographer, his current passion has been repopularizing the moon with amateur astronomy, with the amateur astronomy community. Robert has perfected image processing techniques that allow the amateur astronomer using modest equipment to exceed the quality of Earth-based professional lunar photographs taken during the Apollo era. He enjoys speaking to astronomy conventions and spreading his passion for the moon. He has spoken at Space Fest, Winter Star Party, Apollo Rendezvous, Advanced Imaging Conference, and has spoken twice to Okitat Star Party, Southwest Astronomer Astrophoto Seminars. Robert has also spoken 3 times to the Astro Image and 4 times to Alcon, NEAF, and any AIC, in addition to many presentations to the Texas Star Party. He has also been the Master of Ceremonies at 2 Alcons and 3 times at this Arizona Science and Astronomy Expo. His recent activities include a 5-city speaking tour in China, where he was the first Westerner to address the Chinese astronomy community about the moon. On a light, heartwarming note, asteroid 26591 is named Robert Reeves and is named in his honor, and asteroid 26592, Mary Renfro, bears his wife's name. Robert and Mary Reeves are the only husband and wife team to have sequentially named numbered asteroids. So the pleasure to, I neglected to show these. There's Astro Images, and the one on the left is the, I think he got that at TSP. I really love that picture. He's also prolific on 2 Facebook groups, his own group and the Moon Photography group. So now it is my pleasure to hand the mic over to Robert Reeves for tonight's presentation. It's been requested that we hold all questions until the end. All right, take it away, Robert.
And Robert, if I may chime in beforehand, for those of you who may have questions during the course of the talk tonight, if you'd like to ask those questions in the chat window there at Zoom at the bottom, feel free to do so there. We'll collect those and then call on you throughout the Q&A session afterwards so that you can ask the questions of Robert.
I need to stop sharing.
Okay, well, so let me say that when I was asked to speak to this All Clubs meeting, I was sent a list of previous speakers, and I saw that list dating back, oh gosh, 15 years or so, and I am seriously honored to be included in that really amazing group of people. I'm not sure what I've done to earn a spot in such a prestigious list, but I really appreciate you having me here tonight, and I do enjoy talking about the moon. Most people think of me as having written all these astrophotography books, but that'll only go so far as
getting the public excited about astronomy. Around the 50th anniversary of Apollo, the moon was a big thing again. So I was quite busy promoting the moon, and I was lucky enough to be invited to China to do so. I've the presentation I'm giving tonight, I've given it as far away as Seattle, Space Fest in Tucson, Dallas, to Brazil, Mexico, like I said, 5 cities in China. So get quite a bit of mileage out of this, and everybody seems to enjoy it. So if any of y'all were at last year's, not last week's, but last year's El Dorado Star Party, well, you can tune out and go watch Netflix, because you're going to see the same thing again that I did at El Dorado. So without wasting too much more time, let me see if I can make this work. Go to share screen, and hopefully this will work. Come on. Now, can somebody chime in and see if you see the 365 days of the moon slide? Is it working?
We see your Explorer window.
Yeah, I see a whole bunch of slides.
Okay, here we go again. We did a test run of this a little while ago and it worked. We will figure this out. Okay. Well, it says I am screen sharing. Hopefully you're seeing my 365 Days of the Moon Present slide at this moment.
Not yet. It's still the same screen. I don't know if you're using multiple displays, Robert. If
No,
you
I'm
need to
not.
sort that. No.
I am not. It says I am screen sharing.
Yeah, we do see the screen.
Well, this is irritating. You are screen sharing. I'll try new share.
I was going to say it may be useful to stop the share and try. There we
Oh,
go.
there
Now
it
we
is.
see it.
All righty. I'm afraid to really do anything. I'm going to see if we can make this full screen. And that doesn't work. I think I better leave it be, or it might go bluey on me. Anyway, 365 Days of the Moon. Those of you who are not familiar with what I do, about 5 years ago, I decided to show a different lunar image that I've taken every day for a year and do a little write-up about it and see how it would go. Well, 4 years later, I was still doing it. And this year, it kind of slowed down a little bit. In fact, it stopped because my spare time efforts are now totally tied up with building a house. I'm building it myself. I am the contractor. I am the construction crew. I'm the guy that does it all. So my time is pretty tied up. Just today, I was hanging sheetrock inside the place for quite a while. So my lunar observing time has disappeared lately, but I went up to the observatory today and made sure the spiders haven't taken over, and it still looks good up there. And I pray that I'll be getting back to it. And 365 Days of the Moon will return once I get this house built and everything working. So now the problem is my slides are, there we go. Do you see my title slide? Did that work?
Yes, we do.
Great, now we're going. Okay, we talked about exploring and understanding the moon tonight, and presented to the East Texas Regional All Clubs meeting on today, October 23. And as the 50th anniversary of Apollo is upon us and past now, much has appeared in the media about how we got to the moon and the politics of why we went to the moon and the personalities who engineered, directed, and flew the missions to the moon. But half a century after humans first set foot on another world and explored the moon, how much does the average person actually know about the moon? Well, the answer is surprisingly little. Personally, I've been in love with the moon my entire life. my earliest memories of the moon were watching moonrise through my bedroom window when I was a child. Today, space age explorations have not stripped the wonder and the mystery I felt for the moon when I was young. There is a name for people like me, and it is not lunatic. It's selenophile, a person who loves the moon. And I hope after you understand the moon a little bit more after tonight's presentation, you too will become a selenophile. So those of you who are not familiar with me, uh, in 2000, I published the book Wide Field Astrophotography, and it was well received, but photo technology soon changed after that, and it was the last book written about film-based astrophotography. So I regeared, and in 2005, I published the first book about digital astrophotography, and progressed along and enjoyed my photography. Though I'm well known for my lunar photography, I enjoy deep sky photography through my teleview refractor. And this slide needs to be updated now because now I've managed to get a Celestron 14 with a hyperstar. I've kind of reached the pinnacle of my dreams. And with an amazing filter I got from OPT, the Triad Ultra filter, I can do deep sky photography from my driveway, 20 feet outside the window here, here in the center of San Antonio, and get images similar to this. So it's not your grandfather's astrophotography anymore. So technology was changing, and lunar photography was being done in a different way using webcams and software instead of film. So in 2006, I published the introduction to webcam astrophotography. I like to think that this book helped popularize the use of webcam video capture for planetary photography. And I also like to think that it helped launch today's planetary camera industry, where ZWO, QHY, and for a while Celestron with their Skyra series of cameras, which they have discontinued, really brought lunar and planetary photography into the mainstream for everybody, made it easy, made them be able to do a work that was superior to what the professional world did just a generation ago. Along the way, my lunar photographs have appeared on the covers of magazines or in magazines, some in articles that I wrote. They've appeared on the covers of science fiction books and technical publications, like the same image on a Spanish science fiction novel and on the PhD dissertation of a young Dutch lady who was analyzing the chemical properties of lunar magma. If you have Turn Left at Orion, well, you've got some of my moon pictures in there. My moon pictures are used by some people who collect Apollo astronaut photos. Unfortunately, Al Worden died this year. He's no longer with us. But my moon photos signed by people who walked on the moon. You know, that's pretty cool. I wish I had one of those photos that was signed, but a lot of people use my pictures for that. And when you get down to the nitty gritty of it, some of you may be sitting on one of my moon pictures right now. If you have one of the iPhone covers, cases by spec that has a moon picture on it, you have my moon picture. So over the past 10 years, I've spent a large amount of time chasing big telescopes all over the southern United States in an effort to take high resolution lunar photographs. Very proud to say the C14 behind me on the left is now mine, that very same telescope. I have it now. The 20-inch Ritchie, no, I don't think they're going to let me have that one. But it's up in Waco at the observatory up there. So getting down to the basics, I find that I can take better moon pictures from my own observatory here at home with 7 to 11-inch telescopes than I could with those big telescopes elsewhere, because poor seeing does not degrade the images of smaller telescopes as much as it does in the big ones. I've used 7-inch Maksudovs, 11-inch Celestrons, 8-inch Celestron, even a 20-inch Skywatcher Skywatcher Dob. Some people would think that's not quite the right instrument for the moon, but I got some really, really nice results with it. I do not use the Celestron 14 for the moon. It's too big to fit into my observatory, and using it on the ground in the driveway, the hot concrete just messes up the moon, but doesn't bother the hyperstar at all, so I leave it as an astrograph. So how good is modern lunar imaging with a modest amateur telescope? The image on the right that I'm holding is a plate taken from the famous Kuiper Lunar Atlas. It was the best professional astronomers could do from the Earth in the 1960s. The image on the left was taken from my backyard with a Celestron telescope, Celestron 11 telescope, and a Skyris planetary camera. Well, you judge which is best. They're the same field. One of them is upside down because back in 1960, all lunar charts were printed south up. Nowadays, we've, by convention, inverted it, so the moon is presented the same as terrestrial maps with north up. So to sum up my feelings about what I do, I have no special talent. Over the past, 59 to 61 years, I've been doing astronomy, doing astrophotography. Yeah, you learn a little bit along the way. Don't consider myself an expert. There are people who do better things than I do, but I like to popularize what I do know and spread the word. So I claim I have no special talent, but I am passionately curious. And if you're watching this presentation, you are too. So I hope you learn a little bit along the way here. So the moon is my playground, and I invite you to come out and play with me. Now, when I was young, the moon was a big deal. Back in the 1960s, the moon was a dream. It was a goal and a destination, a place of mystery to be explored by brave heroes who dared to set foot on another world. Then in the mid-1970s, there was a fundamental shift in amateur astronomy. The introduction of the 8-inch Schmidt-Cassegrain gave us a powerful, affordable, portable telescope that opened up the deep sky to amateurs, and the moon faded from our dreams. My goal of this presentation is twofold: to bring the moon back within our astronomical realm. Yes, that's misspelled. It should be realm, not real. To make it something not to be avoided because it interferes with the deep sky, but to be admired in addition to deep sky, and to get you to not just look at the moon, but see and understand it. So today, many astronomers consider the moon boring, a place covered with bumps and holes. But the moon is not visually static. The moon is a geologic wonderground that changes day by day, even hour by hour. There's much to see on the moon once you know what to look for. And I want you to go back to the moon with me and rediscover its wonders. So today we're going to look at the creation of the moon, the evolution of the moon's face, the status, scientific status of the modern moon, and then we're going to explore it through a telescope. The earliest event on the moon was necessarily its creation. Today, our thinking is the moon was created by the collision of a Mars-sized object that shared a similar orbit to the proto-Earth, and eventually the two objects collided anywhere from about 20 to 100 million years after the creation of our solar system. This collision shattered both worlds. And computer simulations have been run that repeatedly show that from the debris of this collision, our Earth was born, and within a matter of days, the moon began to form. And within a matter of years, the moon in its form as we know it came into being. It didn't look like the way it does now, but the physical form was there. Now, an early molten moon, all the iron and heavy radioactive elements sank to the center. The silicates floated to the top in a global magma ocean. And it took millions of years for the moon to solidify. Now, this science fiction vision of a ball of glowing molten rock flying through space. It didn't quite work out that way. The moon was probably, although still molten inside, a very dark body, a chilled skin of solidified rock, uh, likely formed on the exterior and insulated the interior of it to keep it molten for quite a long time. Now, as the moon evolved, it underwent a series of epochs, much like the Earth did with the Jurassic, Triassic, all the fun names we knew when we were kids and really liked dinosaurs. Well, the moon had a similar situation throughout time. The pre-Nectarian, the Nectarian, Imbrium, Eratosthenian, Copernican epochs. They start from the formation of the moon up to about 3.9 billion years ago. Was pre-Nectarian. Then during the Nectarian epoch, about 3.8, 3.9 billion years ago, is a period of intense asteroid bombardment where the modern face of the moon began to take shape. These huge asteroid impacts created the basins on the moon, which later filled with lava, and we now see them as the dark regions that create the face of the man on the moon. This Mare formation occurred during the Imbrium epoch, between 3.1 and about 3.8 billion years ago. Following the Mare formation, this period of post-Mare cratering, where a majority of the craters that we see on the moon now were formed anywhere between 1 and 3 billion years ago. And then the Copernican epoch is the modern moon. Very few craters have been formed since then. The rate of cratering, the impact rate reduced significantly. It is perhaps less than 300, by a factor of 300 less now than it was several billion years ago. And a good thing, because the Earth would shellac just like that. We'd be peppered pretty badly too if this cratering rate hadn't slowed down. Life as we know it on Earth, us tonight here, we wouldn't exist if this cratering rate hadn't slowed down. But between about 1 billion years ago and now, only the craters that display significant ray structure were formed, like Tycho, Copernicus, Kepler, the big bright ray craters. Rays fade after about 1 billion years, and they're a good indicator of the age of more recent craters. If they're a rayed crater, they're fairly young. So the Nectarian epoch, about 3.8, 3.9 billion years ago, the moon looks significantly different. You recognize the extremely large craters, the basins, the huge round impact basins that were created by huge asteroid impacts. These flooded during the Imbrium epoch with repeated lava flows. Extensive volcanism formed the Maria. The basins were obscured by this Mare formation. We have to understand that the basin that a Mare lays in and the Maria that's in the basin are two different things, created by two different forces. The basin was created by an impact. The Maria was created by volcanism, lava coming up from within the moon. Then during the Copernican epoch, like I said, 1 billion years to the present, the young craters still maintain their ray structure and a significant reduction in crater formation. So the two primary landscape forming processes on the moon are volcanism and impact cratering. There is no weathering on the moon from atmosphere or oceans. What happened on the moon stays that way on the moon. Any modification is by subsequent volcanism or impact cratering modifying a pre-existing surface. The Mare regions, volcanic, they're now basalt, relatively few craters, and fairly flat. The highlands, the bright areas of the moon, are the primary magmatic crust from when the moon was formed. It's anorthositic, which means it's made up primarily of a single mineral, heavily cratered and relatively rough. And above all, as big as the moon looks when it rises in a Texas sky, early in the evening, it's still a very distant object. It's 250,000 miles away. It's the only world that human beings have traveled to. And we should feel privileged that we were alive to see that happen. And I pray we'll be alive still when it happens again, but I'm not holding my breath. Oops. So let's go through a summary of our understanding of the physical moon. The moon is not the primordial object we thought it was before the space age. The moon is made of rocky material that has been melted and heavily modified by both exogenic and endogenic forces, that is, impact cratering and volcanism. Two conclusions were drawn about the moon prior to the space age. The moon underwent a huge bombardment about 500 million years after it was formed. That was a late heavy bombardment during the Nectarian epoch. And volcanic activity began on the moon about 70 million years after it was formed and was prevalent for about 1 billion years. This is the Imbrium epoch, when the Mare formation was at its heaviest. After about 50 years of intense research, since the Apollo era, the moon remains lifeless. In the lunar samples that have been returned to Earth, no living organisms, fossils, or organic compounds have been found. The lunar evolution process, through the accretion of smaller bodies, melting, and impacts, have left the moon with a crust about 60 kilometers deep and a uniform lithosphere reaching a depth of about 1,000 kilometers. Below this lies a partially liquid core. There's many theories, but we still do not know for certain if the moon possesses a small iron core. Now, the oldest rocks on the moon are the 4.6 billion year old light-colored highlands known as the Terrae. The youngest rocks on the moon are the 3.2 billion year old Mare formed by volcanic eruptions. Therefore, the youngest rocks on the moon are as old as the oldest rocks on Earth. The Earth and moon formed from the same source material, that collision I mentioned before. Earth and moon evolved similarly, but the moon is depleted in iron and volatile elements. Lunar rocks formed in high temperature events with little chemical reaction with water. Evidence of the earliest events that occurred both on the moon and Earth are now only seen on the moon. Earth's weather and oceans have erased all the geologic evidence of the massive impacts of billions of years ago. Now, lunar rocks can be broadly categorized into 3 types, without getting really crazy about the chemistry of it. The volcanic basalts that erupted from the interior of the moon and formed the Mare, the anorthosites that are the lightweight material that floated to the surface from an early molten moon, and the breccias created by mixing of other rocks crushed by meteorite impacts. After the molten moon solidified, it was blasted by thousands of asteroid impacts during the late heavy bombardment. The largest impacts created the basins that later flooded with lava to form the Mare. And the primordial moon was much closer to the Earth than the modern moon. Many people don't realize it, but when the moon was created, it was about as far away as the modern geosynchronous satellite belt. The moon was enormously closer. The tidal effects on the Earth were fierce. Early oceans had tides of hundreds of feet because of the proximity of the moon. And it is the very action of the tides and the changing shape of ocean shorelines as the Earth evolves because of plate tectonics that drives the slow cycling, slow cyclic recession of the moon from the Earth. The moon is slowly receding away at about 2.5 centimeters per year. So basically, when Neil Armstrong landed on the moon, it was about a yard closer to the Earth than it is today. The crust on the far side is thicker than the near side crust. Most of the basaltic flooding, most of the volcanic flooding that created the basins occurred on the thinner near side crust. And the thinner near side crust allowed volcanic eruptions to reach the surface more easily than the thicker far side. So once this happened, the higher density basalt within the near-side basins displaced the moon's center of gravity just enough to allow the moon to enter a synchronous rotation and keep the same side always facing the Earth. Over the billions of years of its existence, the moon has been blasted by countless meteorite impacts that crushed the upper layer of the crust into a mixture of dust and rock fragments we call regolith. Because impacts excavate rock samples from deep within the moon's crust, if you know where to pick them, it's possible to analyze samples from the interior of the moon. One of the reasons why we have to go back. So that's kind of a nutshell on the scientific standing of the moon now. So let's take a look at what the moon looks like through a telescope, what the various features are, how they interact with each other so we can understand the geology of the moon, what we're looking at, what the mare are, what the mountains are, the craters, the ridges and rills, the scarps, volcanic features on the moon. And then finally, we're going to look at a series of sentimental favorites that we all enjoy looking at as we telescopically scan the moon. So the mare are the most noticeable things. We can see these with the naked eye. They're what form the face of the man of the moon. The mare, or lunar sea, is a field of dark basalt deposited by ancient volcanism. The basins on the moon and the mare lying within them are not the same thing. The basins were created by asteroid impacts. The mare were formed by lava eruptions flooding these basins. Now, not all basins contain a mare. There's about 20 named lunar mare, but there's 50 something recognized basins on the moon. So not all of them flooded. Now the mare define the face of the moon and create the caricature of the man of the moon. And like I said, there are 21 named mare on the near side. 11 were named by Giovanni Riccioli in the 17th century. 8 were named in the 19th and early 20th centuries, and 2 of them were named in the space age since the Apollo landings. You know, Mare Nectaris down in the southeast corner of the moon. You see it's round for a reason. We're going to see a general trend here. Mare Crisium, one of the first seas that we see during the crescent moon as it gets bigger and bigger during the lunation. Crisium is the first one we see. Mare Serenitatis, the Sea of Serenity, also circular. Serenitatis is Sea of Serenity, very aptly named. It's one of the most serene areas on the moon. Only the crater Bessel is a fairly large impact within the expanse of Serenitatis. Well, I think I just mentioned that 17-kilometer Bessel, largest one, least crater to the Mare. Mare Tranquillitatis, where Apollo 11 landed. Basically circular, but you look at it close, it looks more like it's figure 8. I think Tranquillitatis is actually 2 overlapping Mare, creating a figure 8 shape. And of course, the largest of the circular lunar seas, Mare Imbrium, you can clearly see that this thing is cradled in a round depression up at the north by Plato, through the Alps mountains, around through the Apennines and the Caucasus on the south. This is Mare Imbrium is cradled within the rim of the Imbrium Basin, a huge, gigantic impact basin on the moon. The same with Mare Humorum down in the southwest. These are all circular. They were massive impact basins at one time. Now, Nod Duck is Oceanus Procellarum. Procellarum actually exceeds 2 million square kilometers. It is over twice the size of Mare Imbrium, but it is at such a slant angle to us, foreshortened to our view, that even though it's the largest Mare on the moon, it contributes very little to the face of the man on the moon. We really don't notice Procellarum, but Procellarum extends over a huge area of the moon and may overlay along with Imbrium and several other of the Mare. These may overlay a massive impact basin, the Procellarum Basin, that covers half the face of the moon, but it's been obscured by subsequent impacts and volcanic flooding. Mare Austral, down in the southeast. The Austral Basin did not completely fill up with lava flows. It is a collection of basalt-filled craters. And why did this happen? Why didn't it completely flood? Remember, the far side of the moon is thicker. Mare Austral overlaps the limb of the moon. It's partially on the near side, partially on the far side. It is close to or overlays that very that thicker far side that restricts volcanic eruptions. So what lava could come through only filled the bottoms of the craters, didn't completely pave over everything and create a smooth mare. Now, not all mare lie within a single basin. Mare Frigoris, it kind of forms the eyebrow over the eyes of the man on the moon. Frigoris is 1,800 kilometers wide, but only 200 kilometers high. And it may lay in portions of the Procellarum, Imbrium, and Serenitatis basins. I mentioned some were created during the space age, or were named during the space age, I should say. They were created billions of years ago, but they were named during the space age. Mare Cognitum was partitioned from part of Oceanus Procellarum in 1964 and designated as a separate Mare. This was done to commemorate the success of the American Ranger 7 spacecraft that took the first close-up pictures of the moon in 1964. It landed in the Cognitum area. So the whole region was named the sea that was known in honor of Ranger 7. Now, lunar mountains are different than the Earth's. Earth's mountains are continuously created by plate tectonics and volcanism and are eroded by Earth's weather and oceans. Lunar mountains, on the other hand, were created by an entirely different process. Impacts. Lunar mountain chains are the raised rims of impact basins. Individual peaks form at the center of large crater impacts, but by and large, lunar mountains the lunar mountain chains are all the rims of impact basins. And these mountains have remained unchanged since their formation billions of years ago, whereas earthly mountains can significantly be altered by weather and oceans and plate tectonics within 100 million years. Some of the mountains on the moon. We all know dark floored plateau up north of Mare Imbrium. Well, the lunar Alps extend off to the east from Plato and is bisected by the Alpine Valley, a fault that has slumped and created this rift through the mountains. The Caucasus, lunar Caucasus, all the mountains on the moon are named after terrestrial mountain chains. This arcs further along the eastern side of Mare Imbrium. The southeastern part of it, southeastern Imbrium has the Apennine Mountains extending down to the crater Eratosthenes. And finally, just north of Copernicus, we have the Carpathian Mountains forming the southern rim of the Imbrium impact basin. The Cordillera Mountains. These are elusive. You can only see them one day of the month. They are the mountain chain that forms the outer rim of the Oriental impact basin, which straddles the western limb of the moon. Part of it extends to the far side, part of it on the near side. Just 2 days prior to the full moon, this area is still in shadow. A day before full moon, now you can see these mountains because they're casting a shadow. You can see their mountain peaks. You can see a long range of mountains, the rim of an impact basin. During the full moon and afterwards, these shadows disappear and you can no longer see the mountains. They're just lost in the lunar glare. So the Cordillera you get to see for one day a month. The Jura Mountains, they form this horseshoe arc of the Bay of Rainbows on the northwestern shore of Mare Imbrium. another smaller impact basin overlaying the Imbrium basin. Now, some of the prominent mountain chains on the moon, such as the Western Chrysian Basin Impact Ring, remain unnamed. There are many features on the moon that do not have names that deserve them, but there's a convention for naming things. If you're going to apply a name to the moon, it has to be for a research reason to identify something that is being studied. We just can't name something for sentimental reasons on the moon. They're very picky about dropping names on the moon. So the types of craters on the moon. You know, we all think crater is a crater. It's a hole in the ground, right? Well, there are differences. And just like there is a main sequence of stars where they go through, you know, their birth all the way up to red giant, there's a main sequence for craters as well. If it's less than 16 to 21 kilometers in diameter, the dynamics of the impact that formed the crater is only going to leave a simple bowl-shaped depression. If it is larger than 16 to 21 kilometers, the impact creates a shock rebound of the subsurface rock that creates a complex crater with a central peak and a collapsed terrace wall that slumps down into the crater. Then if the crater is larger than 300 kilometers, we don't call it a crater anymore. It is a basin. Examples, Helicon and Leverrier on Mare Imbrium, just simple bowl-shaped depressions. Complex crater, Copernicus is the granddaddy of the examples. Central peaks, collapsed terrace walls that crumbled because they can't support their own weight and tumbled down into the crater and formed a series of terraced walls or terrace steps. And then a example of a basin that did not fill with lava is Bailey, over 300 kilometers in diameter on the southwest limb of the moon. Now, examples of complex craters which feature central peaks and collapsed terrace walls. We've got Pythagoras on the northwestern part of the moon, Moretus on the southern limb, Geminus just north of Mare Crisium. These things are scattered all over the moon. Now, crater rays are composed of pulverized glassy material thrown from a crater by the impact explosion that created the crater. As the crater rays fade after about 1 billion years, and they're an indication that the parent crater is relatively young. Rays are brightest near the full moon because this glassy material reflects light most effectively back toward its source, the sun. And during full moon, the Earth is between the moon and the sun, so we get this bright reflection off of the rays. Now, the Tycho ray system is the largest on the moon, spanning about 2,200 kilometers. But there's a mystery. Why do the railroad tracks to the south and the southwest ray not align with the middle of Tycho? See if my cursor works here. Railroad tracks here, this twin streak, and this rogue ray extending to the southwest. The ray material does not come to a single focus at the center of Tycho, where you would expect it to splash out from. So if you can figure out why, you got your name on a research paper in the Lunar and Planetary Journal. Monodirectional rays, such as those extending from Messier and Messier A, and the butterfly ray pattern, like those extending from Proclus, are an indication of an oblique impact. At a very, very shallow impact angle, no ray material splashes back in the direction the impactor came from. Now, secondary craters are created by impact ejecta thrown by a crater's explosive formation. Secondaries are shallow because the impact speed of the impactor that created it, secondary crater, cannot exceed the 2.4 kilometer escape velocity of the moon. If the material thrown out by the primary impact goes faster, it escapes the moon entirely, goes in orbit around the sun. So secondary craters often lay in linear chains. And it's thought that a majority of craters smaller than 20 kilometers on the moon are believed to be secondary craters. But these secondaries can appear hundreds of kilometers from the primary impact. So it's tough to associate them with a specific impact unless they happen to lie in the linear chains like these secondaries near Copernicus. Another set of odd ducks is the elongated craters. Not all craters are round. In this case, we've got a peanut-shaped crater, Haensel. This is actually two circular impacts merged, overlapped. It's our foreshortened viewing angle that makes it look like a peanut. The same with Ray to E. This is multiple impacts overlapping to create this keyhole-shaped crater. Now Schiller, Schiller is indeed a single oblique impact. Something plowed up the moon royally. This thing is 170 kilometers long. Whatever ripped into here, and it was quite a show when it happened. And again, more craters that aren't round. We've got Anaximander in the northwest, kind of shaped like a Valentine, a lopsided Valentine, but nonetheless. Again, overlapped craters. Meton, my four-leaf clover, good luck charm on the moon. 4 overlapped craters formed during the Nectarian or pre-Nectarian era, and then were subsequently filled with debris that was blasted out by basin impacts and showered down and obscured the multiple merged rims in the middle and created this interesting four-leaf clover pattern. And then, of course, Agrippa and Godin, one is bullet-shaped, the other one's bell-shaped. We've got craters on the moon that are pentagon-shaped, hexagon-shaped. There's even a fairly large one in the north that is square. So not all craters are round. A curious subset of craters are the floor-fractured craters. These started off life as normal complex craters with a central peak, collapsed terrace walls, but lava welled up from underneath, pushed up the crater floor, sometimes flooding it, and creating a series of cracks across the crater floor. Well, that's the hallmark of a floor fractured crater, a series of rills and cracks running across its interior. Gassendi is one of the most famous. Posidonius on Mars Serenitatis is another popular one. Atlas crater up next to Hercules, also floor fractured. Now, ghost craters are pre-existing craters that were buried by Mare-forming lava flows 3 billion years ago. So where there used to be a substantial crater, it's just been paved over like a parking lot with lava. Sometimes we can see evidence of the pre-existing crater, like with Lamont. There's wrinkle ridges that form over the peaks of the buried subsurface crater. And we can see Lamont may actually be a small double-ringed impact basin. Stadius up near Copernicus, is a very round raised rim structure among the secondary craters of Copernicus. Flamsteed P, the area where America's Surveyor 1 spacecraft landed back in 1966, first American soft landing on the moon. Only the crown of the crater rim still protrudes above the lavas. Crater chains on the moon, scientifically known as a catena. Many of you remember the impact of comet Shoemaker-Levy on Jupiter back in the 1990s, where the Jovian gravity broke the comet up and it rained down in a series of impacts on Jupiter, just one after another, like a string of bombs dropped by a World War II bomber. Well, that's what happened on the moon as well. The early Earth-Moon system were much closer together. The combined gravities would break up asteroids and comets so that they would crash onto the moon in a series of impacts instead of a single big wallop. Catena Mueller, an example, Catena Davy. Catena Abel Theta is the longest crater chain on the moon, over 210 kilometers wide. Now, wrinkle ridges add a little bit more spice to the moon. These are known by the scientific name of dorsum or dorsa, and they're folds on the Mars surfaces where sheets of basalt have crushed together and buckled into a lengthy ridge that rarely exceeds several hundred meters in elevation, but it can extend for hundreds of kilometers in length. And wrinkle ridges are generally named after Earth scientists. And the most popular wrinkle ridge is the Serpentine Ridge on eastern Serenitatis, and this is composed of the combined lengths of dorsal Smirnov and dorsal Lister. Here we see dorsum Heim off the western shore of Mare Imbrium, and unnamed wrinkle ridges look like frozen ocean waves washing into the horseshoe bay of Sinus Iridum. And more unnamed wrinkle ridges arc around eastern Mare Humorum. Now, rills, or cracks on the moon, are scientifically known as rima or rimae in the plural, and they are grooves or channels on the moon that are appreciably longer than they are wide. Now, these things are formed by three different processes. The straight rills are formed by the slumping of land between two parallel faults. This is where the crust is split apart by a volcanic dike, or a vertical sheet of magma that pushed up from the moon's molten core, but did not breach the surface as a volcanic eruption. And we see examples like Rima Hesiodus on the left, Rima Sursalis on the right. And Sursalis extends almost 400 kilometers. It's the longest straight rill on the moon. Now, arcuate, or curved rills, are created by the stretching of land near the edge of a maria. As the mass of the Mare basalt within a basin slumps toward the middle of the basin, it pulls open the land near the Mare shore, and in this case is actually created a triple rill system. Kind of looks like a cat scratch around western Mare Humorum. Sinuous rills are formed by flowing streams of lava, much like channels are cut in the earth by flowing water. And in this case, Rima Hadley, the landing target of Apollo 15. And I got to meet Dave Scott, commander of that summer before last. He's still kicking, still enjoying himself. Now, scarps on the moon are scientifically known as rupes and are formed by two processes. Some scarps are the surviving rim of an impact basin, and other scarps are created by land slumping on one side of a fault. In this case, we're looking at Rupus Altai, which is on the southwest corner of Mare Imbrium, Mare Nectaris, and it is the surviving segment of the outer impact ring of the Nectaris basin. Here we see Rupus Cauchy on the south of Cauchy crater. There's Rima Cauchy above it, but Rupus Cauchy is a long cliff-like structure where land is slumped on one side of a fault. And notice the little volcanic domes even further south, little Cauchy domes. Most famous of the scarps on the moon is Straight Wall. We see that after sunrise as a black line feature because of the shadow, but as the sun gets higher and illuminates the cliff face, it becomes a white line feature. And it's one of the early favorite targets of novice lunar observers. Volcanic activity on the moon is evident in the form of pyroclastic deposits, sinuous rills, ash deposits around cinder cones, and volcanic domes. And in this case, we see Schroeder's Valley, the long sinuous rill snaking away across the top of the Aristarchus Plateau. The heart-shaped pyroclastic deposits north of Rima Hyginus, we see it as the dark mountainous region. It has a general shape of a heart, so I call it the heart of the moon. It doesn't have an official name, so I'm free to call it whatever I want. And deposits around the cinder cones and Alphonsus crater, the little dark spots around the tiny craters around the inner rim of the terraced walls of Alphonsus. These evidence of past volcanic eruption on the moon. And volcanic domes, small, tiny shield volcanoes, very small, rarely more than about 10 miles across. There are no huge volcanic Vesuvius type mountains on the moon. All volcanic eruptions either smooth out into the maria or only form these dimple-like small volcanic mounds. We see many of them in the Marias Hills region on Oceanus Procellarum. There's over 200 of them in that area. Or Mons Rumker on northern Oceanus Procellarum, a volcanic mound about 1 kilometer in altitude and topped by about 6 more volcanic domes. So now that we know a little bit about the geology of the moon, what created the face of the moon, how some of these features interact with each other, let's just cruise around the moon with a telescope a little bit and enjoy the view and see if we can recognize some of the things we've been looking at. Plateau crater, of course, started out as a normal complex crater, but filled with lava, completely paved over its interior, and the Lunar Alps Mountains to the east of it. Whoops. Tycho crater at low sun elevation. We don't see the ray structure like we normally do at full moon at low sun elevation, but look closely all around Tycho. There are hundreds and hundreds of tiny pits. And this was created by the secondary craters thrown out from Tycho, rained back down on the surface of the moon, and carved out just hundreds and hundreds of tiny, tiny little secondary craters. The Aristarchus Plateau, volcanic region, elevated, built up by volcanic action, and Schroeder's Valley cutting across the middle of it. Endymion crater at the center, Plateau wannabe, Hercules and Atlas craters in the foreground, the Atlas being a floor fractured crater, and up on the northeast along the limb, the huge basalt area of Mare Humboldtianum. It straddles the lunar limb. Copernicus crater with its ray structure, the second largest ray structure on the moon. The fact that it has a ray structure says it's fairly young. We think it's about 800 million years old. Another view along the Terminator. That's where we like to prowl the most, where the shadows are deepest and features stand in contrast. A bright full moon has no shadows. You can see very little detail, but during the phases, we follow the Terminator, we see the detail. Visit back to Straight Wall, the lunar favorite for everybody. And more lunar rills, the gull wing shaped Rima Hyginus on the left, Rima Aridaeus in the middle, and remember the ghost crater Lamont that looks like a lunar spider off on Mare Tranquillitatis. Too much in this picture to talk about, so we'll just enjoy the view. Lots and lots of things. And you're going to guess I like Lamont. It's just so unusual. That rill structure radiating away from a ridge structure, radiating away from it, makes it look like a spider, like a lunar spider. Cassini at the top, Aristillus, Autolycus in deep shadow. Theophilus, Katharina. Okay. I knew sooner or later I'd be so tired I'd forget a crater name, and I have. Cyrillus, there we go. Okay, upper right. Theophilus, then Cyrillus next to it, and then on the right, Katharina, the study of aging of lunar features. Now, all of these craters are in excess of 3 billion years old, but some are extremely ruined and some look fairly fresh. Katharina formed first and looked probably similar to what Theophilus did 3 billion years ago. And then Cyrillus struck and showered the interior of Katharina with debris, partially burying it. And then comes Theophilus, whacks down right next to Cyrillus and obliterates Cyrillus. So all of these are similar in ages, but first down gets all the heat when the subsequent ones land. So it gives you a good study of the aging of craters, lunar features. The one on top is the youngest. The one on the bottom is the oldest. Mare Humorum, just a fun part of the moon. I just have memories of seeing this when I was very, very young, attracted primarily to the floor fractured crater Gassendi up at the upper left. And a serpentine ridge again running down the eastern shore of Serenitatis, and the floor fractured crater Posidonius. Come back here. Mare Nectaris again, and we can see Theophilus and Cyrillus Catharina along its western ridge. And another view of the Tycho region, this time near sunset. Again, not illuminating the ray structure because the angle of the sun is not reflecting directly back at us. And again, the Mare Crisium, classic example of the circular impact basin flooded with basalt to create a lunar maria. Posidonius crater again. Copernicus just after sunrise. And the Cheshire Cat moon. That's what I call a Cheshire Cat, because in the Alice in Wonderland tale, the Cheshire Cat just faded away until there was nothing left but a smile. And that's what the crescent moon looks like when you see it setting in the western sky just after sunset. Looks like the Cheshire Cat. So, to conclude things, the moon is not just a graveyard for dead philosophers and scientists. The moon is a dynamic world with many, many wonders and scientific delights. The moon is available for viewing most of the month. The moon does not require dark sky. It is a backyard object. And the moon is the only celestial body we can observe with 1 kilometer resolution. So there is much to love on the moon. And I ask you to come join me on my playground. So that's my presentation, and I appreciate your time tonight.
Wonderful presentation, Robert. Thank you so much for that. And I hope you have a little bit more time for some questions, because
Sure.
several of them came flooding in, and I wanted to give those who asked them an opportunity to ask them to you themselves. So first on the list was Will Young. Will, you want to
Go
ask your
for it.
question?
Hey, Robert, thanks, man. That was amazing. I learned something every time I see that presentation. Maxitov or Schmidt-Cassegrain for imaging. What's your favorite?
Well, if I had a bigger Maxitov, I would go with it. I've got a Skywatcher 7-inch, the 180 millimeter Maxitov, and I've got a Celestron 11. When I take pictures with each, I cannot tell them apart. The 7-inch is, a much smaller telescope, but it has such great contrast, such great image contrast. The images are just so sharp in it that it rivals the performance of the Celestron 11. Celestron's not going to like me to say that, but, but that's the way it is. But Celestron also markets their Celestron 700, which is a 7-inch Maxutov. So I'll give that a plug. But I have a tough time telling which is which when I pick up a picture out of the pile. I got to think twice which telescope was this taken with.
Great, thank you. Stephen Blow, did you want to come off mute and ask your question?
Yeah, thank you. Hi, Robert. That presentation was very, very enlightening and enjoyable. Thank you for that.
Well, thank you.
The question is, I heard NASA is going to make an announcement on Monday, quote, an exciting new discovery about the moon. Any speculation on what that might be?
Well, any previews of that have slid under my radar. Like I said, my activities very recently have been very heavily centered around home building. And I haven't really kept up enormously with stuff like that. So I really can't speculate.
Okay. There was an indication from what I read that it was related to deep space exploration. So perhaps some mineral or gas discovery deposits that they could use for fuel or something?
Well, that would probably center on the discovery of more water deposits on the moon, more ice deposits,
Okay.
unless we can effectively utilize lunar water deposits. It's going to be real tough to go there because I mean, you can't send up a freighter every month with just a giant tank of water on it. That's very, very expensive. We've got to learn how to live off the land. Lunar settlements are going to happen. So that's why the push to explore the southern poles, where it's believed that there are ices trapped in the bottom of craters that never receive direct sunlight. So they're probably going to be something related to that, because such a finding would be extraordinarily important to the future of manned lunar exploration.
All right, thank you.
Okay, Chris Morissette, I believe, had a question as well. Chris, do you want to come off mute and ask?
Yes, like everybody else, Robert, wonderful presentation. The moon, has it always been tidally locked with the Earth, or did it ever rotate?
Initially it did. Initially it had its own rotation rate, and the volcanic eruptions eventually created the Maria and the Mascons, which gave the near side just a little bit more mass, and it slowly became locked into a synchronous rotation. And if you study all of the moons of other planets, almost every one of them is the same thing, tidally locked, one face toward the parent planet. It's just a natural thing that happens. Uh, 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 the fact that it is tidally locked in a synchronous rotation is not really that intriguing to me. What is intriguing to me is how the tides and changing shape of shorelines on the Earth affect the recession of the moon away from the Earth, how the moon is slowly shrinking or drifting away from the Earth, and how extraordinary it is that we're alive at the time when it's just by coincidence the size of the moon and the sun are the same diameter in the sky, so we have solar eclipses. In the future, they'll all be annulars. In the past, there were no totals because the moon was so close, it blotted out everything. And here we are just enjoying the heck out of these solar eclipses by sheer chance that evolution put us on this planet at the right time when the moon had receded just the right distance away from the Earth.
That's great perspective, Robert. Yeah. Okay, Justin McCollum, I think you had a question as well.
Yes, I'm curious. Have you ever done any false colored images of the moon? And if so, have you noticed by just solar erosion or micrometeorite dust deposits over many years to have seen any type of changes in just the appearance of features on the moon?
No, all of my photography is done with a monochrome camera because I want maximum sensitivity. I shoot near the terminator where it's very dim. The low sun elevation is not very bright. Plus, I'm operating at very long focal lengths, f/25 or more. Okay. So I need all the sensitivity I can get to do the type of photography I do. Now, there's a fellow in England, and of course, I've completely forgotten his name, even though I know him well, who does enhanced color work, and his stuff is extraordinary. You can see all kinds of mineralogy in his work, and he just does it with a 7-inch Maksudov and a color camera, very similar to what I do, but he does the color work, whereas I don't. So it does show up very well.
I've noticed how those colors have changed over the years with false color images, and you can relate that to micrometeor dust deposits, and then there's solar erosion with sodium and potassium being released, and that has showed some color change, albedo changes on certain features of the moon.
I'm not sure a human being can live long enough to see changes like that because it's a very slow process. The gardening or tilling over of the top several centimeters of lunar surface can take hundreds of thousands of years. So any any changes like that are very long-term phenomena. I just don't think we're going to be around long enough to see it. But we have seen craters on the moon that weren't there just several years ago. That kind of stuff we can see. Lunar Reconnaissance Orbiter mapped the moon early on and it continues to map it. And comparison of early and now photos of regions have shown new craters. Not big ones, but I'm talking about meters or tens of meters in diameter. And that we can see. But tilling away of ray material or different hued regolith, that's a very long-term effect. And I don't think we're going to be able to detect that.
Okay. Sheena Williams, all the way from Washington State, I think had a question. You may have answered it in the previous answer that you had as well. So Sheena, do you want to come off mute and ask?
Yeah, and I don't know if it was like answered all the way, but partially. You're right,
Okay.
Joe. Thank you so much, and hello everyone, and thank you, Robert, for that great talk about the moon. I did learn some things I had no idea about. For instance, one of them, which is kind of like what I had a question about, you were talking about the moon was moving like farther and farther away from Earth.
Yes.
Do you know? I mean, I know you talked about like how much, like I think a centimeter or two a year, but
Yeah.
how long will it continue to move away from us? And is that an issue?
Well, the moon is not going to escape the Earth. The mathematical studies I've seen shows that it goes out to about 500,000 miles out, billions of years from now, and then slowly starts to come back. But before that completes that cycle, the sun is going to run out of fuel, turn into a red giant, and Earth and the moon are both going to go poof. So we're not going to get to that stage before the solar system ends. But mathematically, it's possible if the sun remains stable. But solar evolution, stars evolve, go through their life cycles. Ultimately, the sun will go red giant, and both the Earth and moon are going to get dusted.
Yeah.
Okay, thank you.
Great question, Sheena. All right, Chris Ober, I think, had a question as well next.
Yeah, hi, Robert. Every time I see you speak, I learn something new. Question for, are there any scientific programs that a amateur can contribute to, such as citizen science or anything else?
Well, the one that is probably most relevant is monitoring meteor impacts on the moon. There's a number of programs where people use relatively low magnification to stare at a large area of the moon that is in shadow, still in not illuminated, but in shadow, and watch for bright flashes, things that hit the moon. And this has turned out to be quite successful in a number of instances. There's quite a few lunar impacts that have been recorded this way. It doesn't take that big of a rock to hit the moon at cosmic speeds, 70,000 kilometers an hour. To the kinetic energy will create a considerable flash. It is visible from the Earth. It can be detected using ordinary cameras like the QHY and ZWO cameras. So there's programs for monitoring that. And the reason that's important is eventually we're going to have habitats on the moon. There's going to be a moon base. There's going to be people living there. We would really like to know what's going to be falling on our roof. What do we need to protect ourselves when we're living on the moon? What is the actual expected flux of incoming meteoritic material? We have a general idea of what we might encounter just by studying meteorite frequency on Earth satellites. That's been done since the beginning of the space age. But what actually hits the moon? What's the frequency and size of the objects? And what do we need to protect ourselves from those things? It'd be a really bad day if pretty good sized rock came crashing through your habitat module, and that'd be the end of that. So that particular research program is one that strikes my fancy. It's very applicable to the immediate space age.
Cool. Thank you.
Okay. I know we have several questions, Robert. I want to be mindful of your time. Do you have time for maybe 3 or 4 more?
Yeah, go ahead.
Okay. Debbie Moran, I think, was next in line. Debbie, did you have a question?
Yes. Hi, Robert.
Hey, Debbie.
Hi. Good to see you. My question is about collapsing walls and landslides. Can there be activity, maybe from tidal forces or just sheer gravity over a long period of time on collapsing walls? Will there ever be watch out for falling rock signs on the moon?
Well, there's always a danger of a collapse because the crater walls, they're not stable structures. They're just piles of dirt, basically, and fairly dry at that, unless there's subsurface ice. A nearby substantial impact can cause seismic shaking, which will collapse the crater walls. We've seen evidence of this in numerous places around the moon, where a nearby impact collapsed a crater wall, and you see the material landslided down into the middle of the crater. So it has happened. The frequency of large impacts like that is thankfully slacked off. So it's not something we expect to see like every 10 years, every 100 years, maybe not even 1,000 years. But over a period of hundreds of thousands of years, yes, we're going to see an impact large enough to create a seismic shock that will cause further collapse in some crater structures.
Okay. And next question was Rick Weber or Weber. I apologize for mispronouncing the name.
Hello, Rick.
Come off mute. If not, I can ask the question for him. He said, are the named features internationally recognized?
Well, like features in the sky, there are officially recognized, IAU recognized names, and then there are popular names. There are many features in the sky. We have a popular name for them, like the Swan Nebula or the Bubble Nebula, the Eagle Nebula. Those are not official names; they're popular names. And there's the same thing on the moon, the technical name for straight wall is Rupas Recta, but everybody calls it straight wall. So there is a long list of official names for features on the moon, but there's also a laundry list of popular names features on the moon, and some of them are actually astronaut named features that they named as navigation aids while they were doing the Apollo landings. Some of those are in the popular lexicon now. Some have been officially adopted by the AAU, but many remain as just popular names or just identified as astronaut named features, but not official. So there's both, just like there is in the sky.
Excellent. And buying an acre of land on the moon through Groupon is pretty much not worth the paper it's written on, correct?
Yeah. The chances of getting there, unless you're Elon Musk's really, really good buddy, is probably pretty slim. So right. It's not even bragging rights.
Okay, next question was from Venkatesh Narayan. Venkatesh, are you there?
Yes, I am. And thank you so much, Robert, for the presentation. It was extremely intriguing. And,
thank you.
You mentioned about some names of craters. I wanted to understand if there was a specific name for a crater that is in between 21 to 299, because I didn't see that in your presentation, but I'm just curious.
I'm not sure what you mean by 21.
You said there was there were certain names for craters.
Yes.
And then it was one was 16 to 21. And then,
I was talking about the crater main sequence. I was describing sizes, 16 to 21 kilometers in diameter. The impact will create a simple crater larger than 16 to 21 kilometers in diameter. The dynamics of the impact will create a complex crater. I'm sorry, I misled you on that. The 16 to 21 was referring to the crater size, not a crater name.
right. And what about a crater size that is in between 21 to 299? Is that going to be a complex as well?
Yes. Yeah.
Okay.
Yeah. Well, once you get up to 300, then it becomes a basin, or is classified as a basin.
Awesome. Thank you. Appreciate it.
Okay. And one last question. Aparna Ambersanj, her fourth grade daughter had a question that she was curious
this
about.
is going to be a tough
These
one.
are always the good ones, right? We'll finish on this one. Aparna, are you there?
I'm her sister, so I'm gonna answer for her.
Okay.
So the question is, how far will the moon be away in 10,000 years?
Well, that's easy to calculate. 2.5 centimeters times 10,000. So that would be 20. I'm misplacing a decimal point. Anyway, 2.5 times 10,000. What's that going to come out? Mathematical wizards out there.
About 25,000 or 250 meters roughly.
Yeah. Okay. So
a little less than 3 football fields.
Yeah. So in 10,000 years, the moon will be about 300 yards further away than it is now. It's a pretty slow drift. Like I said, between when Neil Armstrong landed on the moon 50 years ago and today, the moon has only drifted away about 1 yard. So it's going to take its time wandering away. It's going to be with us a while. We don't have to get sentimental about its passing away.
All right. Well, thank you so much, Robert. And I really appreciate the talk. It was educational, as you've heard from everybody else. We've certainly learned a lot and certainly inspired us. I'm looking at the moon out my window right now, and I'm ready to go take my telescope out and look at it when we're done here. So before we're done, David, did you have any parting words?
A couple of other little things. First of all, if everybody could unmute their mic and give Bob a big round of applause for an absolutely wonderful, wonderful talk.
Thank you.
And the last final thing we've got is save the date for 2021. Tracy, Leonard, and I have figured out the dates. Hopefully we'll be through this mess. Friday, October 15th will be the All Clubs meeting at the, hopefully, the Houston Museum of Natural Science at Herman Park. We've had it before. And the Houston A-Day at the Georgia Observatory will be October 16th. Details to follow around that time. All right. Thank you very much for attending. And again, we extend our deep appreciation for Bob for being our speaker tonight.
Thank you. It's been fun.
Thank you, Robert. And thank you, everyone, for joining. The meeting is adjourned. Have a good night, everyone.
And thank you later, David and Joe, for all of your efforts tonight. Well done.
Appreciate it. Thank you, Aaron. Good
Great
night,
job.
everyone.
Great job.
Bye-bye.
Bye.